Okay, so now that we know how to use a graphing calculator to graph a polynomial, we're going to now graph by, I guess, analyzing a table. All right, and tables can be constructed for us using technology still. All right, so your graphing calculator will allow us to do that. But I'm going to use Excel, and we technically can also calculate them by hand by just plugging stuff in. So let's do an example if I want to graph the following. And I think this looks like a nice polynomial. F of x equals 2x cubed plus 6x squared minus 14x plus 12. All right. So let's see. I'm going to work in Excel first here. Sorry. Oh, did I grab this by the right thing? All right. There we go. So here's Excel, and then I'll also show you how to do this on a graphing calculator. So I'll end up sharing this with you guys as a Google Doc, but basically what I have here is I've got a setup that works up to a 5th degree polynomial, and all you do is plug in the coefficients here. So this does not have a 5th degree term, so that would be 0. There's no 4th degree term, so that would be 0. The 3rd degree term, the cubic term, coefficient is 2. And we've got 6, and then negative 14. Let's see, is it working? Oh, don't crash on me now. I'm having my computer doing a lot of stuff. And then my constant is 12. Let's see, is this calculating? Ooh, yeah. All right, that was scary. So I've basically plugged that function into Excel, and I'm using Excel to generate my table for me. And then I've got a couple other controls, I guess, on this where I have my x start. So notice if I change this to like -5, my table will start counting at, once it loads, -5. And then x increment, I can have it count by ones, I can have it count by halves, I can have it basically count by anything I want. So here it is counting it by ones. Now, what we're going to be using the table for is we're interested in analyzing where do x-intercepts occur and where do local extrema occur, right? So max or mins, all right? And we want to do this based off of just looking at the numbers. Now, let's see, I think this window, yeah. So for this equation, it looks like I see one case. I might have this start at, well, let me start at -10, and just to get it kind of a broad stroke of what's going on. So at -10, notice what's happening, right? So this is to the left on the graph, right? It's starting way negative, and it's getting bigger and bigger and bigger, right? Going from -1248 to -834 is an increase, 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 and eventually it becomes positive. All right? So if I asked you guys, let me actually grab a snapshot of this. So if I asked you guys, based off of this table, where do you think an x-intercept occurs, what would your theory be? Like, where do you think an x-intercept would occur? Somewhere between -5 and what? Right, so you're saying somewhere between these two, there must have been an x-intercept. What made you think that? Perfect, and that's absolutely perfect analysis. All right, so in order to find a x-intercept, or zeros, we look for y values that change sign. Come on, don't lag on me now. So that's absolutely perfect analysis. So she ended up looking here and realized that between these two y values. It went from negative to positive, and somewhere between there, the graph must have crossed the x-axis, right? That's the only way it could happen. So our x-intercept occurs somewhere between negative 5 and negative 4. The way I can write that is with an inequality. So negative 5 is less than or equal to x is less than or equal to negative 4. So I know that an x-intercept occurs somewhere between those points. Okay? Now back to Excel. I'm going to try to narrow down my search. So I know that it happens somewhere between negative 5 and negative 4. So I'm going to have this start around negative 5. And it's thinking, there we go. And I'm going to change the increment. I'm going to have it, I could have it count by, I don't know, 0.2s or something like that if I wanted. Actually, tell you what, we'll even have it count by 0.1s because I think I've got enough space. So my increment is 0.1. And here I can get a nice snapshot of the points between negative 5 and negative 4, right? See how I was able to grab a nice representation of that. So basically what I've done there, in terms of a graph, I just zoomed in, all right? Right, I changed my x scale so I'm focused kind of on just the points that I want. So now that I'm zoomed in, between which 2 points do you think the x-intercept occurs? Right? So somewhere between negative 4.8 and negative 4.7. Perfect. Let's see, I need the pencil tool here. So that is somewhere between negative 4.8 is less than x is less than negative 4.7. All right, so that's a perfect analysis of how you try to figure out where an x-intercept occurs. All right, now what if I wanted to figure out where a maximum value occurs?
Wait, question. Why does that is less than or equal to that?
Oh, thank you. Good change. Yeah, I can change that. Bam, bam. Right, and I know that that's true because the sign changed between there. Technically, I guess it would probably just be straight less thans because I know that it's not going to be at negative 4.8 since I know what happens at negative 4.8, and that is not 0. So yeah, technically straight less than signs would probably make the most sense. So if I was thinking about a maximum value occurring, all right, thinking about our graph, all right, a maximum value looks like this, right? So it's on top of a hill. And if I want to find this point, in terms of a table, what would this look like on a table, do you think, as far as these points? Now, actually, in terms of a maximum, I want to point out, I can't just compare 2 points to find a maximum. Because what if I compared this point to this point, and I said, aha, this is a maximum? That's not enough information. I'd have to compare it to I'd have to compare 3 things, right? To find a maximum, I'd have to be able to say that this point was bigger than the one to the left and bigger than one to the right. Right? So I'd have to compare it between kind of 3 points to make sure that it's actually a maximum. I don't want to just compare 2. I want to make sure that it's a local max between the ones all around it. So in terms of tables, what do you think that would look like as far as this goes? How do you think you could spot a maximum?
Wouldn't it just get like higher and higher and higher and just get more?
Perfect, yeah. So it would get higher and higher and higher, and then at some point it would get lower and lower and lower. Okay? And yeah, I think someone just spotted it. So a maximum, actually, so our y values would be increasing. And then start decreasing. Right? And even thinking about this little graph that I get over here, imagine like a roller coaster. You're going up the hill, stop, and then down the hill. You know that you just hit the top of the hill because now you're suddenly walking down. right? You reached the top at some point. You can't be going uphill and then downhill and not have hit a maximum at some point before that. So in terms of this table, I see that from negative 12 to negative 148, let's see, I guess I'll do this in yellow. I don't know if it'll show up that well. Right, that's an increase. Actually, I'll write it over on the side here. So this is an increase from negative 8 to negative 5, increase, negative 5 to negative 2, increase, negative 2 to negative 1, increase, right, negative 120 to negative 18, increase, negative 18 to 36, increase, negative 36 to 54 is an increase, and then 54 to 48 is a decrease, right? So somewhere between these 3 points, there was a maximum because the direction of the graph changed, right? So let's actually zoom in there and find it for real. Well, I guess I'll do our general ones. So a local max occurred, I would say, somewhere between negative 4 is less than x is less than negative 2. And I have to have 3 points to figure out if I have a max or a min. I only needed 2 points to figure out if I had an x-intercept because I just had to figure out if the sign changed. But in order to know if the direction changed, you need 3 points. Okay? So that's why these are 3 points apart. Now, could it occur exactly at negative 3? It could, but we're not 100% certain of that. Because what if the highest point occurs like at negative 2.9 or something? That's technically possible, right? So so let's zoom in on our graph on Excel. Oh, no, I just opened the wrong thing. Blast! It's gonna, yeah. Stop lagging, computer, please. Here we go. Let's go to Excel. So my maximum occurs between negative 4 and negative 2. So I'm going to type negative 4 as my start value. Let's see. Now I've really got my computer doing too much. And to negative 2, I might... Oh, I wonder if I can get all the way to negative 2. Does it show it? Can I fit it all in one fell swoop? Maybe I'll have it count by 0.2s for that. But, I mean, I could just scroll down. I'm just trying to fit it all in one screen so I can have a nice snapshot of it. But so here we go. I've got from negative 4 to negative 2, like that. Paste. And here. So based off of this, where do you think a maximum occurs? Negative 2.8. I think you guys are right. Somewhere around there, right? This is the biggest value in terms of the points nearby, right? And I was increasing, 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 and then suddenly started decreasing again. However, I don't want to just say negative 2.8. I mean, I could use that as an estimate, but I would actually just say, like, my max occurs somewhere between negative 3 is less than x. It's less than negative 2.6. And I guess I'll throw the equals there, but we actually know for sure it's not one of those. So, but at least I'm consistently wrong now, having the less than or equals. I'd rather do it all the same way. So yeah, so once again, I kind of have to base it off of 3 points in order to figure out where it is. But if I was to have an estimate, if you said negative 2.8, I'd say that's fine. Okay? And then how about for a minimum value? What would you describe a minimum, where a minimum would occur?
What if I started to increase?
Right? So, well, I guess I don't need arrows. Right, so I know I have a minimum if I compare it to 3 points, and if I'm decreasing and then suddenly start increasing, right? So y values would be decreasing and then increase. Right? So to analyze a table, I think this time just to get the practice, I'm going to do this portion on the graphing calculator so you guys can follow along with me. So I'm going to find this equation right here. Oh, actually, I do have it. So here's the equation. I'm going to plug this into our graphing calculator. All right, so let's turn our graphing calculators back on. And this is from our previous problem, so I want to change this. But I'm going to go to y equals, and we're going to plug in our problem right here. Now, actually, I think I have it right there. That's all right. Don't worry about that. So that's the problem that we're doing right there. So I'm going to type in 2x to the third plus 6x squared. And there's actually a squared. Oh, no. Look at me. I'm all stuck up in the numerator, or exponent again. Last. I'm going to go over and use the delete key. Delete, 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 delete. Delete. Oh, man, how embarrassing. So 2x cubed plus 6x squared. And then move down. Minus 14x. And plus 12. Right, so I've plugged that in. Now, technically, I know that we could just hit the graph button and we'd spot this right off the bat and we'd know exactly what this looks like. Let's see, let me just make sure. That's the same equation, right? Yep, good. But I want to have a table this time, and it turns out your graphing calculator can also do tables effectively. So if I hit second table right above the graph button, it will give me a table here, and I can scroll up and down, and I can see my points, right? So I can see, okay, where did we say a maximum occurred? It was somewhere between, what, -2 and -3, was it? Yeah, -4 and -3. So I can see that it went from 36 to 54 down to 48. So it's the same information that we saw in Excel, just represented differently. All right, yeah, you've just got a crazy different scale. It's the same function, but I'll show you how to change that. If I go to second and table set, right above window here, man, I'm glad I have nicely trimmed fingernails. That would be so disturbing if I was broadcasting gross, grimy fingernails on the internet. Ugh, terrible. So anyways, for second table setup.
Yeah, mine's like -2.
Yep, so we can change this. So, for instance, I know that it occurred somewhere between, what, -4 and -3. So I'm going to have it start at -4. And in this case, I'm using the negative sign, not the subtract. Okay? And my delta table, that little triangle means delta, or the change, or the increment in the table. We can have that count by 0.1, something like that. Right? So it's counting by tenths. And now if I go to second table, you can see I've got -4, -3.9, -3.8, -3.7, and I actually have that all set up. And based off of our analysis, I could figure out, where the maximum occurs or different things like that. Right? So I could analyze this more closely. So I don't think we have time to necessarily find a minimum. Well, let me just throw a quick graph up of this. Oh, I think our graph is crazy wrong. You don't have to keep up with me. Zoom standard. Yeah, this one, the scale is crazy. Aha, it looks like there's a minimum, though. 0.9? Yeah, if I check the table that way. And it looks like we're just about out of time. I'm getting there. But yeah, I could find a minimum value.
1 through 3 and 11 to 13.
Yeah, so homework's up on the board and on the curriculum map. But I just want to point out that our minimum value occurred between here and here because it was increasing. Wait a minute. Aha, right here. It was decreasing and then increasing. So yeah, so it's somewhere between these three, right? So 0.7 is less than x is less than 0.9. Okay? All right, so thank you guys. You got your homework, and I think we covered